Hi everyone. Mm. Welcome back to Made Easy Academia. So please don't forget to subscribe to our channel, like our video so that others can be able to benefit from these tutorials that we're trying to gather on. So now our main discussion today will be based on heat and temperature. You see, this topic too is just nothing but just a simple and straightforward. Now you may be wondering how heat and temperature are very related. Temperature is the degree, but don't worry about that. If I subscribe, I will gather the materials, write all the definitions, and more examples concerning this one. When we have temperature, temperature is the degree of hotness or coldness of a place or of an object. So what determines if either hot or cold? So how are we going to use that? And it has a unit of temperature. I told you unit in physics is very, very important. Unit of temperature is measured in 3 units, the most important, or 4. We have degree Celsius, we have Kelvin, we have Fahrenheit, and we also have Rankine. Those are the units that we have for the temperature. But the most important one is degree Celsius, Kelvin, and Fahrenheit. You understand? So what determines this one is just like heat. It's a form of energy. Determine the amount that we have in a particular temperature. For example, let's say I have 2 water. If one is 20 degrees Celsius and the other one is 80 degrees Celsius, you can see this one have more temperature than this. So to the one with higher temperature, we have more heat. So you can see here is 80 degrees Celsius. That means it has more heat than the one that have 20 degrees Celsius. So the heat just like determine the amount of temperature. So temperature is the degree of hotness or coldness of a place or of an object. So the unit of temperature, as we mentioned, we said it can be measured either degrees Celsius or Kelvin, Fahrenheit, or Rankine. So we check our materials, we define all this, give an example of that. So another thing that we need to take note in this case is conversion of temperature. Conversion of temperature. How can we convert temperature from one unit to the other? This is just a standard formula. It's a standardized formula that can never be changed. Conversion of temperature. Temperature can be converted from one unit to the other. That's what we are trying to tell us. It can be converted from one unit to other, either from degree Celsius to Kelvin, or from Kelvin back to degree Celsius, or from Fahrenheit to Rankine, or from Fahrenheit to degree Celsius. Anyhow, we have to convert it. I will break it down so that you can know how to convert your temperature. So let's first take a look at maybe how to convert from degree Celsius to Kelvin, or from Kelvin back to degree Celsius. We have a standard formula for that. We normally apply this formula. Temperature in Kelvin is equal to temperature in Celsius plus 273. So please, if you check our materials, I will derive all this one because it has a derivation and more and some explanation concerning that. So if you want to convert the temperature from either degree Celsius to Kelvin or from Kelvin to degree Celsius, we apply this formula. Temperature in Kelvin, this key that we put here means if the value of temperature is in Kelvin is equal to temperature in Celsius plus 273. Let's say, for example, maybe I was asked to convert, maybe they said convert 27 degrees Celsius to Kelvin, for example. I want to convert this value to Kelvin. So I don't need to worry since I know the formula that is temperature in Kelvin is equal to temperature in Celsius plus 273. So the value we have in Celsius is 27. That means I can have temperature in Kelvin is equal to 27 plus 273. So here, 27 plus 273, of course, we are going to have 300 Kelvin. You can see, we change it from Celsius then to where? To Kelvin. Or maybe I was asked to convert it from Kelvin to Celsius. Maybe they said convert 373 Kelvin to degrees Celsius. So I'll just go the same formula that we have. Temperature in Kelvin is equal to temperature in Celsius plus 273. Now, from the problem, the value we have in Kelvin is 373. I can have 373 is equal to temperature in Celsius plus 273. So what is going to be the next step here? Yeah, correct like times. If you correct like times, so here we are going to have, so here If I collect the like times here, so here we have 373. You can see this is plus, right? If the plus comes here, we have minus 273 is equal to temperature in Celsius. So now 373 minus 273, of course, you are going to have 273. And you are going to have 100, and I'm sorry about that. So that means these values are 100 degree what? 100 degree Celsius. So if you have to convert either from Celsius to Kelvin or from Kelvin to Celsius, we apply this standard formula, which is temperature in Kelvin is equal to temperature in Celsius plus 273. So another one, we have to convert it from Fahrenheit to Rankine, or maybe from Fahrenheit to Celsius, or from Celsius to Rankine. So let's see that one too. Let's say we want to convert it from Fahrenheit. Let's say from Fahrenheit to Rankine to degree Celsius, or degree Celsius to Fahrenheit. So anyone we actually use there. We also have a standard formula for that. So we use this one. Temperature in degree Celsius is equal to 5/9 F minus 32. You see, this one is maybe we are given the value of this. Maybe we are given the value of F to be maybe either 80 or whatsoever we are given there. So just make sure that you know the formula. Temperature in Celsius is equal to 5/9 bracket over F minus what? F minus 32. Let's see, for example, maybe they said convert 100 degree Fahrenheit to degree Celsius and to Kelvin as well. You can see maybe they want to complicate the issue, but it's simple and straightforward. Just go to the formula, apply your formula that if you want to convert. So down here, F we have here is 100. Fine. So if I go back to the formula, I have temperature in Celsius is equal to 5/9 F minus 32. So now if I substitute the value of my F, since the value of F you are given the problem is 100, you can have T Celsius is equal to 5/9 100 minus 32. So I hope you are following, right? So we are only trying to convert from one unit to the other here. So just master what you are doing, and there won't be any issue. So now so let me make a simple subtraction here. Let's subtract this one. So here I can have this one to be 5/9. Now 100 minus 32, of course, we are going to have 68, right? Yeah, good. So if you like, you can say 5 times 68 divided by 9, or if you like, call this one anyhow you like, it's still the same thing. 5 multiplied by 68 divided by 9. So if I multiply 5 by this, we have this one to be 340 divided by 9. So if you divide that here, you are going to have this one to be 37.78 degrees Celsius by approximation. So now the analysis able to find is to leave the answer in form of what? Kelvin. So now, since we know that now we have already got the value in form of Kelvin now, in form of Celsius, we can easily convert it to Kelvin using the first formula that we applied. I will say temperature in Kelvin is equal to temperature in Celsius plus 273. So here, the one we have in Celsius is 37.78 plus the one we have here is 273. So 37.78 plus 273, you do that one. So here we are going to have 310.78 Kelvin. You understand? So that's how we normally convert. And even if we have to convert from Fahrenheit to Celsius or from Fahrenheit to Kelvin, so anyhow you do it, just master the formula and the approach of converting the temperature from one unit to the other. So I do mention this in physics. The most important thing that we need to know is the unit. Unit is very, very important because some values might not be specified what you're trying to revert to, but once you know the unit, that is it mass or is it kilogram or is it time, it is seconds or minutes or hours. So whatever they give you the values, just make sure that you master the unit. So now, so for the temperature, since according to what we mentioned, we said it has like 4 units. It can be degrees Celsius or Kelvin, Fahrenheit or Rankine. So now you will be asked to convert from one unit to the other. So once you master the formula, then you're free to apply it. So now the next one is different types of thermometer before we talk about the temperature scale. So I will list them one in our materials. We have different type of temperature thermometer. Thermometer is an instrument that we use to measure the temperature. So we have like a clinical thermometer, platinum resistance thermometer. There are many like that. So we have many. We have thermocouple. So with this, each thermometer they have their own scale. That is, we have upper fixed point. At the same time, we have what we call lower fixed point. I will break it down so that you can understand what I'm trying to talk about here. So temperature scale now. So it is, so let's say we have a thermometer like this. Let's see, this is a thermometer. It's begin for one number and ends somewhere. Let's say we have something like this for thermometer. Okay. If you have a particular number, let's say it started from 0 or any number, or maybe it ended at 100, for example. So where it started from is what we call lower fixed point. I will break it down for temperature scale. Temperature scale. So where it started from is what we call the lower fixed point, and where it ended is what we call upper fixed point. So each unit that we talk about have their own specific scale. So let's say this is a thermometer. Okay. So now let's say this is at 1 point. Let's say it here. We call it lower fixed point. Lower fixed point. So sometimes we call it a ice point. Still the same thing. Or they can call it a freezing point. So it's you have to take note of these three terms. You can use any of these three. Either they use lower fixed point, or they use ice point, or they use a freezing point. So for the one we have here, we call it like this one. Where it started from is what we call the lower fixed point. Hope maybe it end at 100 or numbers. So here we call it a upper fixed point. Upper fixed point, or we call it steam point, or we can call it a boiling point. So anytime they use here in this thing, you have to master that one. So here is called lower fixed point. Lower fixed point is what we call the ice point. The ice point is what we call freezing point. So the same things are applicable to this side also. When we have this side, we call it upper fixed point, or we call it a steam point or boiling point. So each scale that we have their own standard value, either in Celsius scale or Fahrenheit scale or Rankine scale. So let's see how we are going to make use of that. Let's see how we are going to derive them one after the other, either for the Celsius scale or Kelvin scale or Fahrenheit scale. Now, look at this one for the degree Celsius, for Celsius scale. See, the standard can never be changed. For lower fixed point is always 0 degrees Celsius, and upper fixed point is always 100 degrees Celsius. Maybe you are having a problem, and the other problem is in Celsius scale. So the lower fixed point is always 0 degrees Celsius, and the upper fixed point is always 100 degrees Celsius. So now, for the Kelvin scale, it's also standard Kelvin scale. So this one is 273 Kelvin, and upper fixed point is 373 Kelvin. So now, this is for the Celsius scale, while this one is for Kelvin scale. Then we also have for the Fahrenheit scale, that one is given as this. The lower is always 32 degrees Fahrenheit, and the upper is 212 degrees Fahrenheit. So it depends on the problem. So if the scale is in Celsius, we apply. Let me read on there. Let's say this is A, this is B, and this is C. So if the problem is in form of a Celsius, then we apply this scale. If it is a Kelvin scale, we apply the second one. If it is a finite scale, then we apply the third one. So now how are we going to make use of the formula? So please note this term. You can use either upper fixed point, or you can call it steam point, or you can call it a boiling point. Any term they use between these two is the same. Or here you can call it lower fixed point, or ice point, or freezing point. So let's see how we are going to derive the formula so that we know how to apply it. Let's say I have a thermometer like this. Let's say we have thermometer is given as let's say we have A, B, C. You know, with this, A is like what we have. A is just like an upper fixed point, right? So A is just like upper fixed point. Then B is like reading point. Where the thermometer, when you use it either clinical, when you test it, where it read to. This is just like the reading point. Then this is a lower fixed point. So let's see how I'm going to derive that. Please look at it. Look at it too. As from here to here. Then from here to here. Look at it. From reading point to lower fixed point. From upper fixed point to lower fixed point. To me, we have B minus C. Okay. Divided by this one too as a minus C. Look at it. B, the real point, minus C, divided by A minus C. I hope you get that one right. So you can use one. Let's say I'm solving a problem. Let's say I have a scale like this. Maybe I have 100, let's say we have 50, let's say we have 20. If I want to use that approach from here to here, from here to this side as well. So here I can have this one to be 50 minus 20, you see, divided by 100 minus 20. Once you master the formulas, then you are free to go with this scale. Let's see some problems, and now we're going to solve them. Okay, career. Question 1. Question 1. A liquid in glass thermometer. A liquid in glass thermometer is graduated in or represented in millimeter. The upper and lower fixed point of the thermometer are 230 millimeter and 80 millimeter respectively. What is the temperature? What is the temperature? What is the temperature in degrees Celsius when it reads 95 millimeter? So let's look at this. Starts. I think we need to retrieve the marker. Now, so let's look at this problem. They said, you know, I told that we have different type of thermometer. We have clinical thermometer. We have this. We have that. So now, let's see how we are going to make use of this problem. They said, is it working? Is it working? Now, please focus on the figure 2. A liquid in glass thermometer is graduated in millimeter, meaning the thermometer given to us here is in forms of a millimeter. So let's draw it. This is let's use the thermometer in millimeter, right? You know, said the upper fixed point. Here we call upper fixed point, right? The upper fixed point that we have is a 230 millimeter, and the lower fixed point we are given from the problem is a 80 meter, respectively. They now said, what is the temperature in Celsius? You can see that value as the question has specified that you should leave the result in form of Celsius. So which one are we going to apply? Are we going to apply the first scale here, the second one, the third one? Yeah, of course, we are going to apply E because we have to leave the result, or we have to find the value in Celsius. So leave for the Celsius scale that we know. We know for the Celsius scale, we have 0 degrees Celsius as lower fixed point, 100 degrees Celsius as our upper fixed point. They now said we should look for the value in Celsius. Let's say X degrees Celsius. If the thermometer read 95 millimeter, if it read 95 millimeter, you can see just a simple problem. Just compare the two that the way I break it down now from here to here, and here to from here to here, right? So what are we going to have now? That means that we have 95 minus 80 divided by 230 minus 80 for this side then equal to, for this one too as well, we have x minus 0 divided by 100 minus 0. I hope you are following right. No, you're just comparing the two sides. That is 95 minus 80 divided by 230 minus 80 equal to, for the Celsius scale, that's x minus 0 divided by 100 minus 0. So now, I'm going to rush myself here so that you don't have to be patient and solve this. So now for this side, if you have, let's say we have 95 minus 80, that one is nothing but what? It's nothing but 18. So now, let me go out here so that we can do anything. Sorry about that. 95 minus 80, that one is nothing but 15. Then 230 minus 80, what are we going to have? Yeah, good. We are going to have 150 is equal to x minus 0, and we have x all over 100. Let me come again so that you can understand this one very well. 95 minus 80, of course, we are going to have 15. Then 230 minus 80, we are going to have 150, x minus 0, and we have x. 100 minus 0, we are going to have 100. So if I cross multiply here, that is 15 will multiply 100, then 150 will multiply x. So here we can have 150 times x is equal to 15 multiplied by 100. So here 150 times x, we are going to have 150x is equal to 15 times this, and we have 1500. So I'm looking for x now. Divide by 150, divide by 150. So meaning here my x will be, this can cancel this. So this one too, we have 10 degree what? 10 degree Celsius, 1500 divided by 150. So we are going to have 10 degree Celsius. So let's look at another question from the materials. Here they say, suppose a particular Z temperature scale as the boiling point of water is as 65 degrees Z and freezing point at minus 14 degrees Z towards temperature in Fahrenheit, this Fahrenheit scale, would a temperature of T equal to minus 98. So let's look at this together. This is another problem. This is another problem. It's simple and straightforward as well. They said, suppose a particular Z temperature. You know, here the scale they use here is this is a temperature they are using here, Z scale. Oh no. Normally every temperature scale have its own standard unit. You don't forget that I told you this is how we have the scale. This one is what we call upper freeze point, or we call it boiling point. I mentioned that one earlier, or we call it a steam point. Then for this, we call it a lower freeze point, or we call it a freezing point, or we call it a ice point. So please, in case you miss the first one, just write them out. So now the next said, suppose a particular temperature scale has the boiling point of water as 65. That means at the boiling point is 65. So this is boiling point, which is the same thing as upper freeze point. We have to be 65 degrees Z. And freezing point at minus 14. No, I told you earlier that the freezing point is nothing but lower freeze point. So we have this one to be minus 14 degrees Z. So the now said to what temperature in Fahrenheit. Now the question has specified that we should give the result in Fahrenheit scale. So you can see we have Fahrenheit scale, Celsius scale, and Kelvin scale, meaning we are going to apply this. So for the Fahrenheit, scale, we normally, for the lower we have 32, and for the upper we have 212. So with the temperature of T is equal to minus 98. So if it read minus 98, so let's say we have to find the value in Fahrenheit. Let's say use S. If you like, you can use F. So the same method, that is from here to here, from here to here. You understand? From the origin point to the lower freeze point, from the higher freeze point to the upper freeze point to the lower freeze point. The same thing also applicable to this, from here to here, as well from here to here, right? So now, if I do that, so here, let me just close this side. So for the first one, I can have minus 98 minus 14. Why do we have two minus? Because the lower freeze point here also contains negative. So divided by the upper one, that is a 65 minus 14 is equal to them for this side too as well, and we have x minus 32, that is this point to this point, divided by 212 minus 32. So now, if you have minus, that's going to be positive. So here I can have minus 98 plus 14 divided by, so this is minus, I can have 65 plus 14 is equal to x minus 32 divided by 212 minus, I think that's going to be 180. So that is 180. So now, so minus 98. So minus 98 plus 14, we are going to have minus 84. Just like the subtracting. So let me put it here. Just master the scale. What is important here is the scale. Once you master the scale, either Celsius or Kelvin or Fahrenheit, just try to master the scale now. So now, minus 98 plus 14, we have minus 84. So now, so divided by 65 plus 14. So here we have 79 is equal to x minus 32 divided by 180. What's going to be the next step here? Yeah, the cross multiply. If I cross multiply, so here we have 79 bracket over x minus 32 is equal to this one, and we have minus 84 multiplied by 180. So now if I open the bracket of this one, if we open the bracket, 79 times x, we are trying to use the one we have outside here. 79 times x, of course, we are going to have 79x minus 79 multiplied by 32. In there we have 2528. 2528. 84 multiplied by 180. So there we have minus 15120. So now if I correct like times, I will have 79x is equal to minus 15120. So this is minus. When the minus comes here, we are going to have plus 2528. So here we have 79x is equal to, so what I have is minus 12592. So I'm looking for x. So divide by 79. Divide by 79. So x is equal to divide by 79. What we have is 159 degree Fahrenheit. You understand, right? So that's all about the scale. So what's important here is the scale. Once you know the scale, either you have to find the lower fixed point, or the upper fixed point, or the middle one. Just apply, then you'll be able to have your So let me solve one more example, then we move to the next agenda. Let's look at this. Let's look at this one. They said the eyes, or let me just, instead of writing it in form of one problem, let me just write it in form of diagram. Then let's say we have a thermometer like this. We have this to be x. We have this to be 45 millimeter. So here we have going to be 180 millimeter. Then Celsius scale. Here we have Kelvin scale 273 Kelvin, 283 Kelvin, 373 Kelvin. You can see now we have to find the value of x. That means in that problem we are looking for the lower fixed point of that thermometer in millimeter. So anyhow they give you the problem, just interpret it just like the way we follow it the other time. It's from here to here, from here to here, right? So that's going to be 45, right? Minus x, which is the lower limit at the lower fixed point. So what we have is 180 minus the lower fixed point, which is x, equal to the same thing applicable to this, and we have 283 minus, just like from here to here, then from here to here. So because I've already explained that, that's why I did not even emphasize more on that. 283 minus 273, then divided by this one to this one, 2373 minus 273. You understand that, right? Yeah, fine. So here, this is the number, this is the number, we can also write that one. And we have 45 minus x, 180 minus x is equal to 283 minus 273. I think there we are going to have 10, right? That's going to be 10. Then here we are going to have it as 100. To cut our problem to make it more easier, this can cancel this. So what we have left here is 45 minus x is equal to 180 minus x is equal to 1 over 10. You can see the next step is to cross multiply. So down here we have 45 minus x of 10 is equal to 180 minus x. What is the next step here? Just open the bracket. So this times this, we have 450. So 10 times minus x, of course, we are going to have minus 10x is equal to 180 minus x. So if I correct the like times, that means that we have 450. This is positive. It's come here, we have minus 180 is equal to minus x, then plus 10x. So then come with our border. So here, if I do that, 450 minus 180, what are we going to have? We are going to have 270 is equal to minus x plus 10x. Definitely we are going to have 9x, right? Yeah, so divided by 9, so our x is going to be equal to 30 millimeter. So anyhow they give you the problem, just master the scale. The scale is important. Either is in millimeter, is in Celsius, or Kelvin, or Fahrenheit, or Rankine.